All right, so this is a parabola. I know that because the problem says that. I also know that because there's only one squared term. And you know the standard form of a parabola. It's going to be given to you on your test. You don't have to memorize it. The standard form one that I'm going to look at, there's two of them, is the one that has the y squared. There's an x squared parabola and a y squared parabola. So the y squared one looks like this. Y minus k squared equals to 4p x minus h. That you don't have to memorize. The vertex of a parabola happens at h comma k, right? So the opposite of what's with x is called your h. So in this case, I have an x minus 1, so my h is a positive 1. And your k is the opposite of what's with y. So right now I have a y minus 2, so my vertex would be at positive 2. So on my graph, what that looks like is a point at 1, 2. So right here is my vertex. After that, I'm going to find what's called the focal length and the focal width. The focal length is p. I don't know why this doesn't want me to write that. The focal length is p, and the focal width is 4p. The focal width is given to you in the problem. So you can see like there's a 4p right here, and so 16 is in that spot, which makes the focal width 16. That means this parabola is going to be 16 units wide. And then p, I can solve for that. So I can take this equation, 4p equals 16, and I can isolate the p by dividing by 4. So p must be 4. P kind of serves as a radius, and the reason that we don't use the letter R is because a radius goes in all directions, and P actually only goes in 2 directions rather than 4. Sometimes P goes left and right, and sometimes P goes up and down, and that depends on which way the graph opens. So that gets us to this next point. What way does the graph open? So what I notice about this equation is that it's a y squared parabola. I'm used to a traditional x squared parabola. So I know an x squared parabola is my u-shaped parabola, and my negative x squared is my upside down u-shape. So if I have a y squared, I know it's going to be either left or right rather than up or down. And because this 16 here is positive, I know it's going to open in the positive direction. So this would be a left. Sorry, positive would be the right. Right, so if that was a negative 16, it would go to the left. So this is going to open to the right. And that's because it's a positive 16 and it's a y squared. So that brings us back to this focal length of P. So now that I know that the direction is right, I know that the P is going to be the radius per se, but only in the left and right direction. It's not going to go up and down. So I am going to go 4 units to the right of this vertex. And that puts me right here at this point. Right? This distance from here to here is my P value, which is 4. Going the same direction that the graph opens, that P value is going to land you at what's called the focus. Okay? And that's going to be a coordinate point. The coordinate point here is at 5 on the x and 2 on the y. So I'm going to call this 5, 2. I'm also going to use the focal width at this point. The focal width is going to be how wide this opens up. So from the focus, I'm going to split the focal width of 16 in half because a parabola is symmetrical. So I'm going to go half of 16 up and half of 16 down. So 8 up is going to put me here, and then 8 down is going to put me here. So that this total distance is my 4p. That's how wide my graph is. So at this point, I technically could graph my parabola. I know it opens to the right, and it's going to connect through those width points. Right, so that's what the parabola looks like. The only other thing I'm missing is what's called the directrix. So, like I said, this focal length P is kind of called a radius, but it only goes in two directions. We went to the right, the directrix is gonna be the left, that same value, which puts you here. Now, the thing about a directrix is it's not a point, so I'm not gonna write a coordinate point for this. It's a line. The directrix is a line that doesn't go through the graph, so I'm not gonna go like this, because you can see that cuts right through the graph. That's called the axis of symmetry. The directrix goes the opposite way of that. Kind of serves as like a boundary line for my graph. So that's my directrix. It's a little lopsided. And I can see that that directrix goes right through the x-axis at 3, and a vertical line is an x equals equation. So this is x equals -3. This distance from here to here is also p. So you can see the vertex is the center because I'm using both directions to get that p value. And then the focal width is how wide it opens. Hopefully that helps. We're going to do some more practice today on a review guide, and then we're going to have a quiz tomorrow. I know I'm not here the first part of class, so we'll do some notes together the second part of class. I'll be here at 11.